Hello, class. Today, we will be talking about a surprisingly hard problem. It seems very simple, but it is actually very hard. The problem states that triangle ABC is isosceles, with AB equals AC. A is at the 20-degree angle because A didn't want to show up, he was playing hide and seek with me. B at the bottom right-hand corner, and C at the bottom left-hand corner. Please don't ask me your right from your left. If you do, please go back to kindergarten. Find the measure of angle EDB. It's simple, right? It's just angle chasing. It's not. Let's find some angles. We know that the measure of angle ABC equals the measure of angle ACB because triangle ABC is an isosceles triangle. Doing the math, we find that the measure of angle ABC is equal to the measure of angle ACB, which is equal to 80 degrees. And now let's find some more angles. Remember that the three angles in a triangle must sum up to 180 degrees. We can find the measures of angles CDB and CEB this way. Doing the math, we find that the measure of angle CDB is 40 degrees and the measure of angle CEB equals 50 degrees. This also gives us that triangle CBE is isosceles, with segment BC is congruent to segment CE, since angles CEB and BCE are base angles. This congruency is interesting. We will come back to it later. Remember it. Now, we won't make much progress angle chasing after what we did here. So we'll have to come up with something smarter. Let's draw an auxiliary line, BF. F is a point on AC, so that the measure of angle CBF is 20 degrees. Segment BF is congruent to segment BC. Therefore, triangle BCF is isosceles with BC equals BF. This is because the measure of angle CFB must be 80 degrees, because that's the only way that triangle CFB can be a triangle. And now remember equation 1, that segment BC is congruent to segment BE is congruent to segment BF. We will be using this segment congruency in the future. Now let's find more angles, now that we have an auxiliary line. The measure of angle BFC is 80 degrees, so the measure of angle DFB is 100 degrees. Since the measure of angle CDB is 40 degrees, the measure of angle FBD is also 40 degrees. This gives us isosceles triangle DFB with segment DF congruent to segment BF because of the converse of the base angles theorem. So, segment BC is congruent to segment BE, which is congruent to segment BF, which is congruent to segment DF. That was a mouthful. Now, let's draw even more auxiliary lines. From equation 2, we have BF equals BE. Why don't we try building triangle FBE? Because we know that the measure of FBE equals 60, as you can see very clearly in my equation. Triangle FBE is an isosceles triangle with vertex angle 60 degrees, so it is equilateral. I will leave this fact to you. This theorem to prove that if an isosceles triangle has vertex angle 60 degrees, it must be an equilateral triangle. And now on to the mouthful of equation 3. Segment BC is congruent to segment BE, which is congruent to segment BF, which is congruent to segment DF, which is congruent to segment EF. Now let's find even more angles. Since we know that Segment DF is congruent to segment EF from equation 3. Triangle DFE is an isosceles triangle with vertex angle DFE, which after doing the math, we find is 40 degrees. The vertex angle of triangle DFE is 40 degrees, so the base angles must be 70 degrees each. Now we know that one of the base angles has angle EDB in them. That's what we want. So let's see if we can build a linear equation. And now please tell me you know how to solve a linear equation. Because if you don't, I'm sorry, you're going to have to get kicked back to pre-algebra. Now we know that the measure of angle EDF is 70 degrees, but by the angle addition postulate, it is also the measure of angle EDB plus the measure of angle BDC. And we already know that the measure of angle CDB is 40 degrees. So we're left with a simple linear equation. So that gives us the measure of angle EDB is 30 degrees. Special thanks to Art of Problem Solving, which allowed me to put up LaTeX, which is all the cool equations you see. GeoGebra 5, which allowed me to draw two-scale diagrams that even the most OCD person would say is perfect. Artist Jorge Mendez, who created the music, which is Cold from the album Silhouettes. Thank you. We will be working on HMMT problems next week. I don't think it should be that hard, now that we've walked through solving this monster of a problem. Thank you.